we're going to use this example to help us solve number 23 from the homework assignment. It's using a process that's needed when you're not able to take the antiderivative of the function that you would like to take the antiderivative of. So we're still going to start the problem the same way. We're going to take the integral of both sides. And then the problem is that when you go to do that for the right side, the left side is just y, right? But when you go to do this for the right side, it's just not possible. There's no function that has e to the negative x squared as its derivative. So we can't find an explicit way to define this thing. So we just kind of have to leave it how it is. We're going to have to leave it defined by an integral. But you guys know that every time we have a function, instead of writing y, I'm going to write f of x. Every time we have a function that's defined by an integral, we need to put a dummy variable in here so that x doesn't represent too many things. So usually when we do this, we put the top bound of this function as x, and it's convenient when we have the bottom bound as some constant. Previously, it didn't matter what constant we chose. It's going to matter here, so this isn't right, but I'm just going to put a 0 here just for a second, just to try to get you to see why we're going to choose the constant that we chose. So now this function has to do two things. It has to meet the requirement that when I take the derivative of it, I get what I was supposed to get. I get this original function. And right now it does accomplish that. When I take f prime of x, I'm taking the derivative of an integral, bottom bound is a constant, top bound is x, and then I'm just going to plug this x in. So it would work out that the derivative of this is just e to the negative x squared, which I need to have that. However, the other requirement of this isn't met. When I go to take f of 7, I need to get 3. But as it stands now, when I plug 7 into this x, I would get the integral from 0 to 7, which is, not easy to find. It's some random decimal. The area under this curve from 0 to 7 is not something that you just know off the top of your head. So I didn't need this to be a 0. I could have made this to be any constant. So why don't we pick the constant that's most convenient for us, so that when I plug 7 into this f of x, I get something that I instantly know. If I make this bottom bound 7, then when I plug 7 in for x and I make this top bound 7, then I automatically, it's easy to tell that this is just 0, because it's the area under this curve with no width, right? I'm just doing it from 7 to 7, so that's got to be 0. So now at least I know what this is, but it's still not what I want it to be. I want it to be 3. I want it to be that when I plug 7 into this function, I get 3. Well, this seems kind of cheap, but we're just going to add 3 to it. Now it will do what we want it to do. When I plug 7 into this, it'll just be 3. So this seems kind of like cheating, because we didn't really do anything. We didn't really take the antiderivative of this, but we have created a function whose derivative is e to the negative x squared, and when I plug 7 into it, I get 3. So it's good. My kind of way of explaining why this is allowed and why this is even a thing is because, let's say you were taking the sine inverse of something that you could do, in your head, hopefully, the sine inverse of 1/2. So that's really asking us the sine of what angle is a half. And I hope you know that that's pi over 6. So we can rewrite this thing in a friendlier notation that's just pi over 6. But what if I didn't know what the sine inverse of something was? Let's say I wanted to know the sine inverse of 0.8. I don't know. Off the top of my head, we don't know what the sine inverse of 0.8 is. So there's not really a friendlier way to write that than just leaving it as a sine inverse of 0.8. That's kind of what's going on here. And all the other examples that we did, we found a way to simplify this antiderivative. And we wrote it by, taking the antiderivative and solving for c. Here and here, that's just not possible. We just have to leave it in the ugly format.